Hello, everyone. Thank you guys for taking time out of your schedules to come out and hear Mr. Brooks speak today. I have the honor of introducing Mr. Jason Brooks, who received his Bachelor's Arts in Mathematics from Maryville College, his Bachelor of Science in Civil Engineering from the University of Tennessee, and his MBA from Tennessee Tech. He is now the president and CEO of LDA Engineering, and he has worked with many different organizations such as the American Water Works Association and the Water Environment Federation. But closer to home, he also serves on Maryville College's board of directors. And today he's going to be giving us some insight into engineering career pathways. So please help me welcome Mr. Jason Brooks.
Does it help if I use this mic for the recording? Okay. I feel a little limited by it though. I was going to rip it off here and walk up and down. just thank you for the introduction. I will take this off and move around a bit, but I won't move far. Well, it's nice to see all of you this afternoon, actually. Pretty cool that you all would spend some time with me, and maybe the title of the presentation was the most inviting thing, more so than me, I hope. What I hope to accomplish today is I do want to share a little bit about the profession I've chosen, and how I think it benefits communities and their society at large. But I also want to dispel the idea that engineering is only for engineers. And I'll talk a little bit about that process of engineering. Many of you are probably more familiar with the scientific process that you're probably studying quite often these days. And maybe folks don't talk about the engineering as a process that much. We think about engineers. I grew up in a small town, just a little north of here, Tazewell, Tennessee. Anybody know where Tazewell is? I thought so. Yeah, I've got one hand back here. Cool. Are you from East Tennessee? Okay, that's fine. So it's, a small, rural, somewhat farming community, light industrial, those kind of things. I thought engineers mostly drove trains. So there weren't very many engineers in my hometown, maybe a couple, but no one to really share with me what the process was. So when I came to Maryville College in 1992, just a few years ago, actually noticed the picture of Anderson Hall back there when it got struck by lightning. I was here on campus when it happened. So I watched the building unfortunately burn, but I think the upside was we got this nice building. Or not Anderson, Fairweather. So having the opportunity that you all have to be exposed, this is really neat to have professionals that can come in and share this, and I'm happy to do it. And expose you to both the profession of engineering that I do very formally. You see that little PE up there by my name? That means I'm a licensed professional engineer. I'm proud to be that. I think it's an important part of becoming an engineer and establishing your credibility. But again, I also want to dispel the notion that only engineers use this process. We'll talk more about that. A little bit about my story. I shared with you where I grew up. I came here in 1992. I was a student athlete. I played football. I initially chose biology as my major. That didn't work out too well. But fortunately, the benefit of the liberal arts education that all of you are having now, I was taking a statistics class. And Margie Ribble, most of you guys may not know Dr. Ribble, wonderful lady. She was here on campus when I was, thankfully, had her class. I was struggling in biology. I was doing well in her statistics class, and she convinced me that maybe math was a better path for me. And my intention was to teach. And somewhere along the path, I ventured in a different direction. I stayed with my math major, but I elected that maybe teaching wasn't my future. But I was pretty far into the major, and I decided that that's what I'd stay with. And I happened to pick up an internship my junior year with Knoxville Utilities Board. And that opportunity later led me to pursue a second bachelor's degree in engineering. So I kind of found my way into engineering is more so than chose that path. But now I have that experience in hindsight. I'm happy to share it with you. Maybe you'll choose engineering as a path, but again, very transparent. I want to share the engineering processes for many, many people. After I left KUB 12 years ago, I had the opportunity to join LDA Engineering as the president and CEO. And so I'll mostly talk about engineering and the process from that perspective. But I've had a lot of opportunities over almost a 30-year career now, which is a little bit humbling that it's been that long. But a lot of experiences in sort of finding my way into the profession. And what I want to stress about that as it relates to where you are currently, I think one of the benefits of the education you're receiving here is that commitment to lifelong learning. And I'll talk about how I think that ties into the engineering process. Now, I would like this to be more of a conversation. I know I'm up here at the lectern, and this is a college campus, and you all are used to being lectured. But certainly, as we go along, feel free to hold your hand up and ask a question. I'm happy to do that, and we'll just have a conversation. I'll try to wrap. How much time do we have? About halfway. Okay, so I'll try to save enough time for us just to talk at the end. Okay? All right. One of my favorite authors, some of you may have heard of this gentleman, Start With Why, Simon Sinek. Now, if you don't want to read the book, one of the easy things to do is just go on YouTube and Google Simon Sinek, Start With Why. It'll be a 20-minute video pop up. It's really interesting video. They'll talk about a lot of brands you recognize, but Sinek's primary objective is to really get us to connect to why we're doing something. And for me, engineering has been an experience where I kind of through practice learned over time maybe what my why was. For us at LDA, and for me personally, we've began to state it like this: stronger, happier communities. Now, I'm a civil engineer, so that means I work with public infrastructure a lot. Some of you may have seen in the news this morning the unfortunate incident in Baltimore where we know at least 2 lives, 2 souls were lost, and a lot of infrastructure, many, many lives are going to be impacted. Often when that type of infrastructure fails, we begin to appreciate the work of the engineer, especially in the civil space. But that's what we do. That's unfortunate that that's happened, but one of the things our profession does is a commitment to serving public health, safety, and welfare as we continue to aspire each time a failure like that happens, or each opportunity we get to prevent a failure like that from happening. That's what our profession aspires to do. These are some of the communities our company serves. That was our first 4 way back in 1982. And over the last several years, we've started to add a lot of communities. Those logos may not be as familiar to each of you. Some of you may be from some of those areas. But our current footprint of our company in the communities we serve, primarily in Tennessee, but also North Carolina, South Carolina, and parts of Kentucky and Virginia, are the areas that we seek to serve. I'm going to share this video with you. I think it does a really good job of connecting you with the type of projects that we do to help make stronger, happier communities. This is in Nashville. If I recognize that spot, Lower Broadway, Nashville. had a lot of Nashville in there. Get a little East Tennessee mountains there at the end. So let me ask you guys a question. So poll the audience. What after watching that video, what in your mind, what defines a strong, happy, thriving community? You can just say one word, a couple of you. Safety. Another one?
Healthy structure.
Healthy.
Resilient.
Resilient. Infrastructure. So you saw a lot of mobility. The surface projects are easy to show. Everybody recognizes them. Everybody uses them. You know, whether it's, you saw sidewalks, transit stations, certainly a lot of lane miles of roadway. What maybe you didn't see were the curb lines, the underground drainage, the water utility system, the telecom utility system, the electric system, all that stuff that's kind of hidden and out of sight, but it's critically important. Just like as we discussed earlier, as Baltimore begins to work through this tragic event of the bridge collapse, the next big challenge is, okay, you got, it's an area where there's a lot of goods and materials being moved. How are they going to address that? And so having good quality infrastructure is critical to resiliency in a thriving community. You guys have been in here in the Maryville, Alcoa, Blount County community for some time now, maybe just a little bit for some of you, maybe a few more years for others, but we live in a place where we have good mobility. We have good infrastructure that supports jobs and recreation. And I think each of you experience the benefits that comes from having that. If you've been to places where that doesn't exist as well, you certainly can compare what that's like. Share with you just another project. This is one that has become kind of a showcase project for us. This is in Johnson City. Anybody been to Johnson City recently? So if you've been downtown by East Tennessee State, between East Tennessee State University, which is kind of to this side of the picture, looking back at downtown. That's the downtown Johnson City area right there. Prior to this project, downtown flooded fairly frequently. A lot of these buildings were boarded up because, you know, the amount of flooding that would come in and damage the first level floors just really didn't lend itself to sustainable businesses. Prior to this is a beautiful green space with nice sidewalks. You can imagine folks out here walking, and there's concerts that happen. There's a little outdoor amphitheater over here. Prior to this, the picture on the left is Founders Park. So you can see a little bit maybe down to the back side of the picture, the warehouses that were sitting on top of this green space. So one of the things that had happened over time is Johnson City was a little more of an industrialized town. You can see this railroad. You can see the railroad tracks kind of running right through the heart of downtown. Give you some hint that it was probably a fairly heavy industrial area, right? In fact, a lot of this was somewhat contaminated. I wouldn't characterize it as very contaminated, but certainly there was some cleanup to go on. It's not uncommon along these railways in smaller little suburban towns like that. But you can imagine what that looked like. And so the creek had been channelized, so it was in a box culvert. See that box culvert. And so this box culvert would fill up, water would start to build up behind it, and water starts to get under pressure, and downtown was sitting downtown from now this rapid flow that was coming in downtown. There's another creek kind of runs along the backside of the downtown area as we're looking at the picture. the confluence of those two creeks were right at the heart of downtown. So all this water just building up in here. We were presented with this problem that had been going on for years. And one of our engineers said, you know, we really need to get that water out of the channelized state and put it back more in a natural flow where it slows down a little bit, doesn't hit downtown so quickly. And geez, it would be nice if we could store some of this water that's going downtown. If we could just hold it back a little bit, and kind of a reservoir. You're familiar with lakes and the way a dam works, you kind of holding that water back. Same principles, much smaller application, same principle. So this is actually a storage system of sorts. We only need it at certain times a year, so there could have been an approach where, well, let's just dig a big hole, pour some concrete, and we'll hold the water in there. But as we begin to formulate a better strategy that applied to a broader sense of users, we only need that when it's raining, and really when it's raining a lot. The rest of the time, that concrete box would just be sitting in the open, right? Probably fenced off and looking horrible. So as we partnered with landscape architects and other professionals, we began to formulate, conceptualize what this might be. A green space that during flooding conditions could be flooded. There's nothing in there that can't be underwater. Even those lights are up high enough that they're out at elevation, and the electrical controls are protected. So we're able to create this beautiful space that has had major impacts on Johnson City. Now the downtown has come back, it's very thriving. Some of you may have still be a little bit young to enjoy Yeehaw Brewery, but it's right there. One of the first businesses that moved into this little depot building and restored that building. They did have a little Tupelo Honey over here that had moved in. I think Tupelo Honey's moved on, and maybe there's a new restaurant in there now. There's a Wild Wings Cafe up here. So all these little businesses popping up around this facility. And then downtown has also started to come back because it's not flooding every other week. So again, you see how nice green space mobility begins to affect the community overall. Another thing we do at LDA is one of my personal values that I bring to our team is philanthropy. And so I think our first Tennessee Future City competition was 6 years ago. So that'd be what, 2018? I think that's right. I think the smile down here on this young man, I think we can probably predict where he might end up with that orange suit. But that smile is really why we do it. So the Future City competition is a middle school competition. It's a national competition that is owned by 3 or 4 organizations: American Society of Civil Engineers, the National Society of Professional Engineers. There's a few of the professional organizations that have kind of put this concept together. And it's been around for, I think, around 30 years. And so the national competition directed at middle school students, and it's really to invite, it's driven by professional engineering organizations, but it's the idea of the competition is that you dream of a city, a future city 100 years out. There's a theme given. This year's theme was energy. And so the students are given a theme to use the engineering process. And ideally, it's a cross-sectional group. So we really want to recruit students that are not only interested in engineering, but politics, sociology, science, other professions, psychology. It's really directed at thinking about how do we make a city strong, resilient, thrive using the engineering process. So the selfish goal for those of us that are engineers is, again, to share this process in the hopes that of the thousands of students that participate, maybe we attract 25% more than we're currently attracting into the engineering profession. But the bigger goal is to again, dispel the idea, the myth that engineering is only for engineers. That's actually a process that after we talk through it some more, maybe you'll discover you use it maybe a little bit every day. But that smile, that's my why. Seeing this young man happy, that's his model. His team's not in the picture, but you know, they dressed up. They got to come to the Tickle College of Engineering over at UT and share their work. And to see that smile, I'm pretty confident that that young man might have an interest in engineering. This is our team. This is something else we do. We obviously work and provide engineering services as a business. So we're working for clients like Metro Nashville. We're obviously doing that with the intent to get a return on investment. But at the same time, we're reinvesting in the community with activities like this. So this is the Metro Nashville Beautification Adopt a Street program. That's some of our team members out working just this week, picking up trash along Fifth Avenue there in Nashville, over by Nissan Stadium. And then finally, I think it's important to stay familiar with our personal why. This is my little personal community. My wife and I were just married a year ago. We have a blended family, so 5 kids. And so each day I'm still getting up, doing what I do, and she's getting up, doing what she does to keep our little community strong. I think it's important. When I played here, our head coach was well known for saying, "Remember who you are." And at first, it was kind of like, okay, I know who I am, but so what's that abstract comment mean? And over time, especially now, as I've gotten closer to probably that, heck, I may be a little older than he was when he was coaching me, but it's taken some time to really become familiar with what his intent of that comment was. It's just understanding that as individuals, when we go out and do what we do, we do why we do it. There are people that we are influencing their lives each and every day. And so he thought it was important that we remember who we are when we're out, maybe confronting choices that at the time might not have been in the best interest of ourselves individually, our team, our college campus. So that's stuck with me. So that's my group there. I'll take a breath for a minute. Any questions or comments? Any questions about any of the projects or things you saw up there?
I have one, if that's okay. So in the Johnson City project, that actually goes underwater during flooding times, or is there a way to control the water down under, or it's just wet?
It stays, so it's difficult to see in the 2-dimensional picture there. But that, you see the creek channel going through the park. You can even see some of these steps coming up to give you some indication that there's a climb in elevation. And certainly on this side, this railway here forms a pretty big berm of sorts. So it's a lot higher on this side and this side. So as the creek channel starts to back up, as it starts to get more and more water down here in this flat part of the city, it starts to slow down and starts to want to back up. It just backs up into this area. So the park would be underwater. So if you were out there and say it's a 2-inch rain in a single day, you're probably not going to see the water any higher than this channel. If it's a 4 or 5-inch rain over the 24-hour period, there's going to be some water up in here. Much better in here than down here. Good question. Others? It's my brief hydraulics lesson for you.
Is there a reason that like a lawn was chosen instead of like more of a like riparian kind of like environment for that?
So I think yes, because the intent was to make a park. So a riparian area would, and is not not an uncommon use when dealing with flooding, because you're gonna get, in addition to primarily storage here. You do have some grassy areas and some riparian zone along the creek channel, but it's really not going to act as, say, a wetland would in a more natural setting. But we have learned over time to use engineered wetlands in places like this. Again, the intent here was to create green space. If you have a riparian zone, you don't necessarily want everybody walking in it. It needs to be a little more protected. I will share with you, if you've been to the duck pond in Alcoa, you may have been to the duck pond. So as you're making your way around that boardwalk, there's a couple of places where you'll see right along the pond, there's some engineered riparian zones along that stretch. And what we did that project too. And in that case, we were trying to intercept stormwater coming off the parking lot that would make its way direct into the pond. And you see this little oil sheen pretty often there at the pond. It wasn't enough to really cause any type of fish kill or aquatic problem, but it looked bad. It was kind of nasty. So the idea was that we could introduce some riparian area, some engineered wetland area, and get some treatment performance out of those before it went into the pond. And moreover, serve as kind of an education piece. How do you use riparian zones or wetlands in areas where you're trying to not only control water, but also gain some additional treatment? The earth does a wonderful job of treating our water when it has enough time. Makes sense. So when it rains in natural terrain that hasn't been disturbed too much, in other words, we've not beat it to death and put stuff on it or covered it up with asphalt and concrete, the earth will do a really good job of cleaning the water up. Really good job. But we demand so much of it, and we can't depend on that as our sole source anymore. Good question. Any other questions? I'm getting a little deep into engineering detail on these, but happy to do that. All right, the engineering process. Has anybody seen this before? I know you all are probably familiar with the scientific process, right? So one of the things that the Future City competition does is really drive this process home with the students. This and in a very project-centric fashion. But really the intent is to get the student experiencing this process. You see that it's cyclical. Any theories on why we put it in a circle as opposed to, I mean, most people think engineering is very linear, right? A, B, C, D, we're following the script. But in this case, this is circular. Any thoughts on why? What do we know about a circle? It doesn't what? It doesn't stop. And so that's why we do this. The engineering process really never ends. One of the differences I like to talk about, and I'm not trying to be disparaging to our colleagues in the science field, but one of the things that's important about engineering is we advance the science often before it's finished. And so sometimes the scientific process demands that to carry it out, it needs a lot more study. But what we know in the practice of engineering, and that's why we call it a practice, is that we're really advancing material use and other structures, other technologies, often before the science would have said it's ready. So it's practice. And one of the things we learn in practicing engineering is to use failures. And it's an important aspect. We do not wish to use the type of failures we saw this morning in Baltimore. Those are tragic and unfortunate, but we will. There will be a team of forensic people start to study and understand that. In this case, it doesn't necessarily look like a structural failure that occurred just on its own. Obviously, there was a strike by a ship. But nonetheless, part of our job as engineers is to understand how things move around the structures that we design. And maybe why that encounter occurred, and could that have been engineered out to prevent that? So understanding failures are an important part of what we do. One of the ways we can advance the science without putting people at risk, lives at risk, by putting something out too fast, is to model. Okay, we do a lot of modeling. Technology has brought that capability so far along. In fact, one of the things we're working on in their company right now is how to use advanced LiDAR techniques and surveying techniques that we can use we can bring a scanner into this building and we can we can hit every point in this room and have a model within a pretty short amount of time of exactly what this room looks like. And so using that technology along with other modeling techniques allows us to really study and advance how we're applying certain engineering techniques to certain problems. I will tell you that one of the biggest challenges we have as professional engineers, bringing new, recently graduated or maybe a little more inexperienced engineers into practice, is the first two steps. Well, I say first two, they don't look like the first two. Ask and imagine. The reason I think that my hypothesis is that when I was going through undergrad engineering and really undergrad as a math student, most of the time, almost all the time, at the end of a lecture, at the end of a week, we were given a problem set. And in that problem set, there was always we either wrote it down or it was printed out in the homework assignment that we were handed out. And there was a statement at the beginning of every one of those, at least in the engineering work. I can't remember if we had this in my math study or not, but probably. But there was a word. What do y'all think that word was? Anybody? It's a tough one. The given. So every solution set that I did as a civil engineering student, I had to write the given at the top of the solution set, turn it in. The given. What I didn't realize was that in practice, nobody was going to hand us the given. And so that becomes kind of the tough part. And then the imagine part really is starting to develop that conceptual solutions. So once we discover what the problem is, or what the challenge is, or what the opportunity is, then we're confronted with, okay, I've got this toolbox. Because really, solution sets in engineering really start here. At least that's what we thought. And we're starting here. Okay, I'm designing a clarifier that's going to have X amount of water passing through it, and it's got these constituents in it, and I need to have this much removal by the end of the process. And I start to put that down, and then my creation might look like, although not as often in school, but the next step in practice would be I start to draw those plans, right? And in this scenario, we're really talking about improved, being we built it, and is it working? Is it doing what it said? In actualities, often we want to model that, maybe in a pilot study or desktop model, some other application before we put it out in the world. We want to test it. But then as we discover things, we're back to, okay, let's figure out how can we improve on the model or what we built and do that. But this is really the challenging area. And it's a lot of times because as students coming out, I was a working student when I went back to engineering school. So I was working for KUB. So I had some context clues. And I understood, especially in the water classes, the hydraulics classes I took, I really understood, okay, this all makes sense to me because every day we're doing this. I'd look around the room and a lot of the students were kind of like, okay, where's the problem set? We'll go work on it, crank the calculations and turn that in and get my grade. So it's really, in professional practice, one of the requirements to get your license is that you, in addition to passing the competency test, we have to spend 4 years in practice before we can be licensed. It's learning how to do this. And this is really the hardest part, especially so in civil engineering, infrastructure engineering, and even environmental. So that's a very, I've actually considered myself to be an environmental engineer, but it's kind of a sub-discipline of civil, sometimes chemical. We'll argue over who gets it. Starting to emerge as its own discipline now. But we're often confronted with, well, how do we figure that out? Who owns the infrastructure? More importantly, who uses it? Well, everybody, right? And of everybody, how many are engineers? Very small percentage. So we struggle with who do we ask? And then how do we start to imagine? Imagine the mobility projects that we do. Who do you all think one of the biggest considerations when we're doing a mobility project? Who do you think is one of the first things we start to think about, or we should think about? It actually took a federal act to kind of wake us up to it. Any stabs at it? Yeah, great answer. That's it. That's it. Now, you'll see a lot of places, in case you didn't hear that, it's disability. So the American Disabilities Act was the federal act that said, hey, engineering professionals and people that own and operate public infrastructure, you need to give consideration to this. Because there are places you will see where there's a sidewalk and you're thinking, how does a wheelchair user get off the curb? Because there's no cut, right? So actually Metro Nashville is under a federal consent decree because one of the big things, when they built a lot of the sidewalks back prior to the American Disability Act, they didn't have curb cuts. So you wheelchair up to a curb and it's a 6-inch drop minimum to get off the curb. So those are all important context things that we need as engineering professionals to hear from our users. So that's not necessarily, it is an engineering solution ultimately, but not necessarily might not be where we start naturally. If I'm trying to design a roadway with an adjacent sidewalk, where really my primary concern is moving traffic. So this is the big challenge. Now, the reason I think it's important is, remember earlier, I wanted to dispel the notion that only engineers are using that. What's my time like?
10 minutes.
10 minutes, okay. That only engineers are using this process. Because imagine each day when you do your own personal to-do list, as you're thinking forward, maybe not about, okay, I gotta clean my room up. But as you're thinking forward about spring break trips, summer internships, a lot of these things are coming into play, right? We use this process every day. And so it's for all of you. To meet the spirit of my title, this is for all of you. I hope that some of you, maybe all of you, will choose it as your profession, because it's a wonderful profession. It really is. You saw some of the neat things we get to do. That's just a little snippet. Sometimes it's a little mundane and a little out of sight. And we're designing things like sewer systems, and we work in landfills. It's not always the nicest smelling, cleanest areas, but we know it's important work. All right. This is us. This is our representation of the engineering process. For us, learn is that ask, imagine step, right? So when we say learn at LDA, that's what we're talking about. We want to learn where we're applying these solutions and how it's going to impact the people that are going to ultimately use it. And then we go to work. And remember, we're practicing the best we can. We don't get it right every time. But we're designing solutions, and then we're working as advocates for our clients and the communities we serve to help them propel those projects forward, to help them get that sidewalk, to help get that transit station, to make sure the water's clean, to make sure the trash gets picked up and put away properly. Those are the things we're doing. Here's a few things, our core values and what we think is important. And I think these can be broadly applied. We've developed these for the folks that we recruit. This is how we teach to do things at LDA, but I think these are important things. I think this one says a lot about just the engineering nature. You know, you like to tinker. You're curious to understand how things work and operate. If we have that curiosity, we'll do those first two steps. We'll ask questions. We'll imagine solutions, because it's just a curiosity. It's a drive. Committed to the process. This one I think is very important for us, because sometimes not every person that comes into our profession is committed to those first two steps. Often they're just committed to the last three. I'll come up with the solution set and then I'll design the drawings and you'll have that. Good luck. That's not us. We're committed to that process, especially those first two steps. Responsible. I do want to share these with you too, by the way. I'll let y'all pass these out while I'm wrapping up. This is really responsible is about accountability. So as professional engineers, we have a responsibility, certainly. Both a legal one, but also an ethical and moral one. And we take that very seriously. It should not be taken to the literal point where we no longer ask and imagine. In other words, we get so bent on protecting public health, safety, and welfare that we lose our innovative state. But as long as we keep that in mind as our ultimate commitment, our ultimate responsibility, then we're allowed to push the envelope and innovate. No, dropped it. All right. We're hungry to solve problems. The best engineers, the good ones, are always looking for those opportunities, some of which you saw earlier. The notion that, hey, we need to get this creek out of the channel, and maybe in doing so, create a nice green space. Well, that was that hunger to not just say, okay, we got a downtown flooding problem. Let's build a concrete box and store this water. That's the only way it'll work. You know, we were hungry to do, we got to do something better than that. It's also the engineer that's gritty, resourceful, and just digs in. You know, this is a challenging problem. I'm not going to relent until we figure out how to correct it, how to make it better, whatever our objective is. I'm not giving up on it. And then finally, we engineered. Now, we did add one in there a little later that's not up there, that's courageous. And that's really about being willing to push that envelope, like I said earlier. It's acknowledging our commitment to the community to protect public health, safety, and welfare, but also having the courage to say, yeah, but I think maybe there's a different approach here. And I've got the resourcefulness and the grittiness just to figure it out. Again, this is a process, and it's one we're very committed to doing and committed to sharing each opportunity we get. That's it. Questions for me? Got about 5 minutes?
Yeah.
Okay.
And can I,
What are qualities that you see in upcoming engineers, and what are successful traits that engineers have?
Well, I think a lot of the ones I just saw, the biggest one, is a curiosity to problem solve. That it's more than just give me the solution set and I'll crank out the calculations. There's a curiosity to drive deeper into what's the context behind this challenge. Why is the landfill important? Why is a tertiary drinking water system important? I just had to use tertiary. I don't. Advanced water treatment system. Why is that important? Just that hunger to understand where engineering solutions fit into a broader space. Certainly the standard qualifiers is you got to be smart. I will say that oftentimes I see engineering schools too quickly cut good engineers because of classes like differential equations, physics, Calc 3. These are all the ones that about got me. And they were here.
Half of my differential equations class is here right now, so you heard them all go.
Right. Hey, it's a tough class. But here's what I would say. Grind through it. The grittiness that gets you through that class, and it was hard on my GPA, but I still have that PE by my name. Right? And I've practiced for almost 30 years now. So I think grit, resourcefulness, you got to be willing to take differential equations and finish it. That's a standard qualifier. But when you're done, you'll be ready for the next level of engineering. And you might not do any more differential equations.
To expand on that a little bit, could you speak to what you maybe had to give up during that process and the like act of pursuing your PE license? Like what were the shifts you had to make all that happen?
Yeah, so as I shared, I went back. So I finished my math degree here and I went back as a civil engineering student. I sacrificed mostly sleep. There were a lot, I worked all day. I was married. I did finish those degrees before my children came along, luckily, but still, it was a lot. So I sacrificed a lot of sleep, I think. Probably time having fun too. I still found time for that. Who's first?
Hey.
Go ahead.
Like, what does a normal day, like, as an engineer at LGA, like, look like?
Yeah, so my normal day is a little different than probably it used to be. I mean, I would say for a lot of our younger engineering staff, I want them out of the office. I don't want necessarily, we're not trying to develop engineers into CAD professionals. CAD is computer aided design or computer aided drafting. A lot of those tools have started to bring engineering analysis into the software. And so there's a tendency to get drug into that and not necessarily be out where the context clues are happening. So we have to be disciplined and say, get out there. But there is a lot of desk time where you are doing analysis, you are doing calculations, you are preparing drawings, you're reviewing drawings. You're reviewing specifications, you're looking at new equipment. But it's important to balance that to go see, well, where are we putting the equipment? If we're going to put in a roundabout, what's the intersection actually look like? Not just from Google, but when I stand at it and I see people around it, what's that look like? So there needs to be time out in the field. We have a CAD professional position. It's shrunk over time. It's typically like a 2-year associate's type degree person, but engineers squeezing over in, the software's done it too, has eroded that professional. But we still recruit that professional and try to have those in place. So when it comes to heavy drawing production or data production, we look to other professionals. I think the engineers need to be out engineering. That's my personal opinion. Other questions?
Was there any courses you would take for WT or
the question was, are there any other courses that I wish I would have taken? So I think you shared that I have an MBA right? I think if your aspiration is to practice engineering, especially in really any of them, some basic finance, and possibly accounting, those two at a minimum. The language of finance and the language of accounting are important because engineering schools do not do a good job of teaching it. I had an engineering econ class that was just marginal. Fortunately for me, I had studied business already, but being able to understand when you do economic analysis of a project, a lot of the decision makers that hold the purse strings, the budget, are not engineers. And you got to be able to talk their language too. So I think that's a good second language to know. That's what I would say. Another question?
So going off of that, would you like consider like a minor business or a minor in statistics or like some?
Yes, I would. I just ran out of time. So I stayed an extra semester. I wanted to play another year of football. And so I had little time. And I picked up, I think, one short of a business minor. I just ran out of time. So I went to graduate school to do that. But yes, a minor, if you've got the room and the tenacity to do it, I think that looks great. One of the things an employer is going to look for is grit. And if you say, hey, I was an engineering major or a science major and I picked up a minor in business for this purpose, that's pretty strong. You got time for one more? One more?
How do the different engineering like subfields work together on projects? And how does that look in the field?
Yeah, so a lot of air projects, again, the surface level projects are always the best to show. Because everybody experiences traffic and transportation every day. But we do a lot of facility projects like treatment plants, water treatment plants. So in those cases, you've got structural, electrical, you've got mechanical, plumbing type engineering, you've got the civil environmental piece. So all those projects rely, as you really get down into the details of a facility like that, everybody's got to start to pull together their piece of the overall design. So if you were to pull up a set of plans, for example, for a water treatment plant, you'll flip through there, there'll be a cover page that tells you where everything is, and it'll be broken down by discipline. So each engineer, structural, mechanical, electrical, civil, will design their piece, and there will be one engineer that kind of pulls it all together and stamps the front cover. But it's a very multidisciplined approach. Some less than others. Transportation doesn't quite rely on, you get structural and mostly civil. But yeah, it's especially in public infrastructure. Definitely a lot of interaction. Did I answer that question? All right, I think that's probably enough.
Yeah, let's thank our speaker.